locus of the two planar components. So for an example, so if you have your electric field intensity something like this, so you have to take the first planar component as capital X and the second one as Y. And for different values of the time, you find out the different points. Okay. And the moment once you find the different points and you put it in a diagram. So let us take this is my x-axis and this is my y-axis. So for an example, at time t is equal to 0, if your point is here, and time t is equal to t by 4, let me say it is here, and time t is equal to t by 2, it is here. So as the time advances, if you find out the locus of all these x and y, and if all the points are lying on a straight line, then you can say the type of polarization is nothing but linear polarization. In the same way, for different values of the time, initially suppose if we have time t equal to 0 here, slightly advance in the time, the point may be somewhere here. And as the time advances, if all the points are located on a circle, that can be said to be a circular polarization. And similarly, as the time advances, if all the points are making a locus of ellipse, we can call it as an elliptical polarization. So to keep it simple, for you find out for different values of the time, what is the value of x and y. In this case, z value can be considered anything. So you need not to worry about the value of z. Vary the value of time and find out the different points. If the locus forms a straight line, it is a linear polarization. If the locus forms a circle, it is a circular polarization, and hence your elliptical polarization if it forms a ellipse. Okay, so I was writing the two different planar components separately. You can understand it better. So this is my first planar component, sorry, EOX, and this is my second planar component. So both are having the different magnitude and different phase. So when I can say that particular electric field is said to be linearly polarized was, so what is an equation? So for different values of the time, the locus should form this equation. You know the straight line linear equation. So it should satisfy the equation called y is equal to mx. So where m is nothing but the slope. So in other words, if we take the ratio of y by x, it should be a constant. So if you take the ratio of y by x, when it is going to be a constant. So in that case, what should be the value of your theta? Can you reply? So when I say this will form a linear polarization, provided the ratio of y by x should be some constant. That is possible when both the phase terms should get cancelled. So then only you can say this will be some constant. So in this case, your theta value has to be equal to 0 degrees. So when you see any equation for electric field, if you are saying it's a linearly polarized, straight away, the phase difference between two planar components must be 0 degrees. What about amplitudes? The amplitudes can be same or it can be different. So if EOX and EOY values can be same or it can be different. So if it is same, you will get the ratio as 1. And if it is different, you will get other than 1. But the condition is here, to satisfy the linear polarized, the phase difference has to be exactly equal to 0 degrees. So can you tell me an example of circular polarization? What should be the phase shift? What will be the condition for phase shift for circular polarization? Can you work out and tell me? Phase shift will be 90 degrees, very good. And what about the amplitudes? What about the amplitudes? Amplitude must be same. Correct, very good. So let us consider an example something like this. the circle equation will be x square plus y square is equal to sum r square. So this is an example of your circle. And what I said, if you draw the locus of all x and y for different values of time, you should form a circle. So when you see in a circle, whatever the component on the x-axis, it should be same on the y-axis. Because on the circle, everywhere radius remains same. So as per the magnitude is concerned, both has to be same. For circular polarization, the amplitude must be equal. This is your first criteria you have to verify. And similarly, what should be the phase condition? 90 degrees. Because if it is sine theta, this has to become cos theta. Then only we'll get x square plus y square will be constant. So let us take an example. Your EOX and EOY will be equal to 1. And omega t minus beta z is theta. So this will be theta plus theta in this case. So it will be sine theta and this is cos theta. So if you take the square and sum, so sine square theta plus cos square theta, you are going to get 1. So it will satisfy the circular equation provided the phase difference should be exactly 90 degrees. So your theta has to be 90 degrees. So is it clear? Anything you want me to explain? Yeah. Now, can you give conditions for the elliptical polarized? Can you give the conditions for an elliptical polarized wave? What should be the amplitudes? First, tell me what somebody is having a question. Why do we get the polarization? Why do we get the polarization? What does that mean? Polarization is nothing but, see, as I said you, the type of polarization, you have to be more specific, I think. So the type of polarization, you can call it as a linear because you are having two components. There is no problem if you had only one component. If you skip off this second component and if there is only electric field is oriented in x direction, there is no problem. You can straight away say it is linearly polarized and specifically in x direction. And this linear, circular and elliptical, all these things and all coming into picture if we had two components. So you have two components. So the type of polarization is nothing but for different values of the time, you can see how these planar component is going to behave. So at time t is equal to 0, your x component will be located somewhere and y component will be located somewhere. So you join all those coordinates and find out for different values of the time what are the different points coming. And you join all the points. If after joining all the points, if you get a straight line, you can say it's a linear. And if all the points are forming a circular, you can call it as a circular. So it is just only the distinction how you can make it from one equation to the other. So something like if you want to distinguish from one type of wave to the other type of wave, you need this kind of discrimination.
So,
yeah.
In case of electromagnetic waves, we'll be having this kind of polarization.
Correct. Till now we have not seen that. Yeah. But till now what we have seen was electric field is oriented in only one direction. But there are cases where the electric field is having two components.
Then direction of magnetic field
will also be same thing. I will give an example. When I was going for the oblique incidence, I was going to give an explanation. The direction of magnetic field can be having one direction as well as a two direction. It again depends upon your direction of propagation. So see here, your direction of propagation is in E cross H, right? So suppose if your propagation is having two components, I will give an example. Let us say your propagation lies in the XZ plane. So correspondingly, you may have your electric field in XZ plane and magnetic field in Y. So is it satisfies the relation? I was giving an example where the wave propagates in the XZ plane and my electric field also lies in the XZ plane. Till now what you seen is a uniform plane wave. Forget about that. Don't compare with that. So this is another type of wave where the wave propagates in my xz plane and the electric field also lies in the xz plane and the magnetic field is in y. So is this equation correct or not?
Yes, sir.
Yeah, because if you see here, x cross y, you are going to get one z component. And similarly, if you take z cross y, you are going to get the x component. Now you understood right now?
Yes, sir.
So in this case, your electric field is having two components, magnetic field is having only one component, but still the direction of propagation is having two components.
Yes, sir.
Yeah, clear?
Thank you.
Yeah.
Yes.
Then tell me the conditions for the elliptical polarized right now. So amplitudes different. Is it must or maybe? So for elliptical, it must be different or it need not to be different. What is the condition I can consider? It must be different. Exactly. You can see here in an ellipse, the major axis along x direction may not be the same length along the y direction. So as per the amplitude part is concerned, it must be different. And what about the phase shift? So quickly tell me what is the phase shift then? You can reply. What will be the phase shift for elliptical polarization? (90°). Does it the case? Suppose in this case, your major axis is making an angle of 90° with respect to your x-axis. You may have an ellipse in this case. In this case, what is the value? I mean, in this case, if the ellipse is like this, the vertical axis is coinciding with y. So in this case, you are having a 90° phase shift. So when you have an ellipse something like this, the vertical axis makes an angle of other than 90° with your x-axis. So the ellipse can be oriented at any angle. So that time you may have other than 90° also. So this is an example where your ellipse is 90° making an angle with horizontal axis or x-axis, major axis. But whereas if we consider an ellipse in this case, the vertical axis is making an angle of other than 90°. This is not 90° now. So there are different orientations of the ellipse can exist. Thing is, what I can say the phase difference can be anything, but it will not be 0°. It can be anything except 0°. So can you tell me what will happen if it is 0°? What will happen if it becomes 0°? Very good. Linear. It is going to become linear, right? Fine. That's it. So if I summarize all the conditions now, so for the linear condition, if any equation is given, and remember this is only for the electric fields. So if any equation is given, you can say the type of polarization is linear provided if the phase difference is 0°. And the second condition, you can say the type of polarization is circular provided you see the amplitude part, amplitude must be equal, and between the two planar components your phase difference should be 90°. And you can call it as an elliptical polarization provided first condition, your amplitude must be different, it should not be same. And the second condition, your phase angle should be other than 0, it can be anything. So these are the three conditions which is very, very important to define the type of polarization. So do you have any questions? If you have any questions, you can clear it, or else you can straight away take an example. Okay, then we'll discuss. If you have any doubt, you'll see the problem, then you can understand it much better. So there are some 5 equations has been given. And your job is here now. Tell me what is the type of polarization, each one. So look at A, B, C, D, and E. You know all the conditions. You just verify and define what is the type of polarization. So you can take time, and once you are done with that, you can share the answers here. Yeah, you can go ahead now. So first you can complete all the things, then I can give an explanation. It is easier for me to do. Yeah, tell me quick. First one, what is your answers?
Linear, sir.
First one linear, second one,
Ellipse, sir.
third one,
Circle, sir.
fourth one,
Ellipse.
good. Fifth one,
Circle, sir.
sir, very good, very good, good. So once again, if anybody not done, I will repeat it here. So you can see here for the first component, so x component and y component both will be multiplied with e power minus j beta z. So which means that x component and y component will have the same phase. So in your case, your phase difference is 0 degrees. So when the phase is 0 degrees, you can straight away call it as a linear. So whereas in the second one, so the first component is having a magnitude 2 and the second component is having a magnitude of 3. So the magnitudes are unequal. And what about the phase here? The magnitude is unequal means it can be linear also, but you have to check the phase. So this will be sine theta and this will be cos theta. So there is a phase shift of 90 degrees. So what will happen? Unequal magnitude and phase is non-zero. So this is said to be your elliptical. Right? And the next third one. Same thing, see here. The first component is having a magnitude of 1. And the second one, if you see the modulus of j, this also is having the magnitude 1. So as per the magnitude is concerned, both are having same. And what about phase shift now? So the first one is getting multiplied with some term here. And the second one is getting multiplied with j. So in the previous class, I told you, j can be written as e power j by 2. Though the magnitude is same, the addition of the j is contributing for 90 degrees phase shift compared to your first component. So what happens here? The magnitude is equal, but the second term is having a phase of 90 degrees. So the same magnitude and 90 degrees phase shift, you have seen this is nothing but your circular. Similarly, you can see the fourth one. Here magnitude is 1 and here magnitude is something minus 2, you can say. But still, the phase for the first one and phase for the second one is going to vary by an angle of j. So for the first one, nothing is there, means first one phase shift will be 0 degrees. For the second one, magnitude is minus 2 and the phase shift is 90 degrees because of j. So finally what happens? Different amplitude and phase is other than 0 degrees. So it is an example of your elliptical. And the last one you can see here, same magnitude. And one is sine theta, the other one is a cos theta. So there is a 90 degrees phase shift. So same magnitude and 90 degrees phase shift. So it will corresponding to circular polarization. So is it clear for everybody? Yeah. But this is not the things that you are expecting in GATE. There is much more things are there which you need to discuss it. This is just only the introduction. So when you go to the circular polarization and elliptical polarization, there are again in turn there are two classifications. Is it a right circular polarized or a left circular polarized? Or is it a right elliptical or left elliptical? That is what more important here. Okay, next thing we'll do that one only. So we'll take the fifth one. So all of you consider the fifth one as an example. Of course, it is in circular. Now we will see whether it is a right circular or left circular. So we'll proceed with that. So I have taken the fifth one. So 2 sin omega t minus beta z ax cap plus 2 cos omega t minus beta z ay cap. So determine whether it is a right circularly polarized or left circularly polarized. So there are actually, if you see the textbook, you may not be able to understand what is actually the type of polarization it is. So I was going to tell you a prescribed approach, step by step you have to follow, then only your answer is going to be correct. So starting from the first point, I need your attention here. So when any problem is given and if you identify it's a circular polarization, it is very important the procedure you have to concentrate whether it is right circular or left circular. Okay, for that, so the first step what you have to do was you split the given electric field into two components. Okay, in this case my planar component is x and y. So I can consider this as capital X and this as capital Y. So I can consider capital X is equal to 2 sine omega t. And as I said earlier, the type of polarization when you are defining, your Z is not going to bother you. It's always the varying time and find out what is the values of X and Y. So when you are varying with respect to time, your Z can be your convenient choice. So in this case, the problem can be simplified if I assume Z equal to 0. It doesn't mean that you always take Z equal to 0 based upon your flexibility. In this case, if I make Z equal to 0, my problem becomes simpler so that the first one is simply become 2 sin omega t and Y becomes 2 cos omega t. Z has nothing to do with the type of polarization. That is the reason why I have assumed Z equal to 0 in this case. So any questions in the first step you have? So take the equation and split it into two parts and fix the value of Z equal to 0 for the convenient choice. So any questions here? Yeah. Next thing, there is a first thumb rule I was going to define it here, which is very, very, very important. So first of all, you have to identify what all those planar components. In this example, it is X and Y. So if you consider another problem, it can be Y and Z also. It can be X and Z also. So what is the first thumb rule you have to follow is whatever the horizontal direction you are taking into vertical direction, you should consider outside. Suppose what is the meaning of that? So finally, next step, what you are going to do, you are going to vary the time and you are going to get X and Y values. So when you are plotting X versus Y, one person can take X as horizontal and Y as vertical. And the other person can take Y as horizontal, X as vertical. So ultimately the answer has to come same for both. So there should be a common rule. So that is the reason why there is a thumb rule I was going to introduce by making that my horizontal direction is X if you are taking and vertical direction Y if you are taking. Then in this case, what is your outside represents as per this one? Horizontal cross vertical means, yeah, horizontal is X direction and vertical is Y direction. So positive Z direction represents outside the board. So you can assume that X is horizontal, vertical, and in this case, you can assume positive Z is coming outside of my paper, you can say. So positive AZ is outside and consequently your negative AZ will obviously become into the board. Okay, now you quickly tell me what will happen if Y is horizontal and Z is vertical. So you may consider other problem where Y will be one component, Z will be another component. So subjected to this, Y is horizontal and Z is vertical, which is outside the plane? Positive X will be outside the plane, good, and negative X will be into the plane, good. Similarly, last one, if you take x as horizontal and z as vertical, which is outside the plane? Very good. Negative y will be out and positive y will be in. So is the first thumb rule clear for everybody? So you see what all those planar component, accordingly you select that rule. So the first thumb rule says what horizontal axis you taken and vertical axis you have taken, the cross product of horizontal and vertical, the corresponding direction you should consider outside the plane. Okay, so do you have any questions now? Yeah, so once again we will come back to our discussion only. In our case, our x value will be 2 sin omega t and y is equal to 2 omega t. Fine. And now as an example, I have taken x as horizontal and my y as my vertical. So subjected to this, so positive z will be outside the board, negative into the board. Right. Now the next will vary the value of time. So let us say time t is equal to 0. So tell me of x and y. So at time t is equal to your omega t is also 0. So your x will become 0, y will become 2. So the point corresponding to 0, 2. So if I locate the point 0, 2, it will be located on the somewhere here, right? On the y-axis, your x component will be 0. So this is your 0, 2 subjected to time t is equal to 0. So let me increase the value of time. So I can take some t by 4. So when you take t is equal to t by 4, what is the value omega t? So 2 pi by t into t by 4. So that you are going to get t by 2, pi by 2. So when you take time is equal to 1/4 of the time period, your omega t will become pi by 2. Currently, your x will become 2 and y will become 0. So where the point lies now? 2, 0. So what is the condition? 2, 0 will be somewhere here. So 2, 0 at time t is equal to t by 4. So tell me what is the value at time t is equal to t by 2? If you do it and tell me at time t is equal to t by 2, what is the value of x and y? Do it quickly. 0, 2, fine. 2 pi by t into t by 2, you are going to get pi. So your x value becomes 0, y value will become -2. So this will be 0, -2. So 0, -2, if I plot it here, maybe somewhere here, 0, -2, subject to t is equal to t. Now, what is your observation here? Everybody tell me. As the time advances, so starting from 0, t by 4 and t by 2, how the local all your points are moving? Is it moving in a clockwise direction or in anti-clockwise direction? Of course, it is moving in circular, I will agree. But now in this case, as the time advances, if you are going in increasing value of time, how you have to move? You have to move in a clockwise or anti-clockwise? Good. At time t is equal to 0, you are here. Slightly increase in the time, you have reached this point, and still increase at this point. So you are moving in the clockwise direction. Correct? Now the final step, everybody have to be more focused. If you want to define whether it is right circular or left circular, there is another thumb rule. You can start with any one of your hand. You start with your right hand or left hand. It doesn't matter. So make sure that the thumb has to be placed in the direct direction. So what is the meaning of that was, see, in this example, everybody tell me what direction of propagation? Look at the equation. There is the direction of propagation. Positive z, specifically speaking, positive z, right? So in the given example, your direction of propagation is in the positive z, but as per your convention, first thumb rule, what it says? As per first thumb rule, the positive az is pointing outside the plane or into the plane? Outside the plane. Very good. So the second thumb rule says that the thumb has to be placed in the direction of propagation. In this case, you have to start with by placing the thumb outside the plane of the pen. Okay. Is it clear, second thumb rule? You can reply anything is, if you want to know, you can understand. So the second thumb rule says you start with any of your hand. Like we have seen the Fleming's right hand and left hand principle, right? The same way you have to start with your hand. But you start with your any of your, it doesn't matter. Suppose all of you take your right hand and make sure that the thumb is pointing outside the plane of the paper. That time, what is the locus of other finger shows? Sir, could you please repeat? Yeah, I will once again repeat after this one. So as of now, you can see here, I thumb rule. If anybody not clear, I will explain again. No need to worry. Just see here. The second thumb rule says that my thumb has to be placed in the outside the plane of paper. So do what I say, everybody. So start with your right hand and place your thumb outside the plane of the paper. What is the locus of other finger shows? Anti-clockwise. So when you are starting with your right hand, it is showing anti-clockwise. Very good. But what is the locus of the points you got here? What is the locus of the points you are getting right now? Clockwise. So it's a pure mismatch, right? So when you start with your right hand, by placing the thumb outside, your finger shows the anti-clockwise, but the point shows the clockwise. So it's a complete mismatch. So you leave your right hand. Now you start with your left hand, all of you. So start with your left hand. Make sure that the thumb is pointing outside the plane of the paper. So what is the locus of other finger shows? So when you start with your left hand, place the thumb outside, the locus of other finger shows clockwise. So right now, is it matching to the points or not? Yeah. So which hand is satisfying right now? So your left hand is satisfying. So the answer is left circular polarized. I know it looks to be slightly confusing, all these steps and that, but this is how actually you need to do. This is the simplest method to define whether it is a right circular or left circular. So whatever the hand is satisfying, that will be said to be that type of polarity. So in this example, my left hand is matching to the locus of the points. So since I can say left circularly polarized. Okay, all of you once again carefully listen. I will repeat the entire procedure one more time, step by step. So the first step, when any problem is given, split it into two planar components. So when you are split into two planar components, my advice was you take the value of z equal to 0 for the simplification purpose. And the second step, you decide which is your horizontal axis and which is your vertical axis. Because you are having x is one variable, y is another variable, you are going to locate all the values of x and y. So for that, first thumb rule is very helpful. So what is the first thumb rule says? Thumb rule 1. So the horizontal cross well should always be the outside. So suppose if you plot the points by taking x as horizontal and y as vertical, so in this case your x cross y should be the outside direction. So which means that your Z direction will be outside and negative Z will be into the plane. So once you are done with the first thumb rule, I hope this rest of the procedure will be simple. You vary the value of time and find out the different points and plot it. So in this example, time t is equal to 0 is here, and time t equal to t by 4 here, time t equal to t by 2 here. So what happened here, as the time advances, the locus of the points is moving in the clockwise fashion. So we identified that it is a clockwise. And the next final step, if you want to decide whether it is a right circular or left circular, you should concentrate on the second thumb rule. So you read the second thumb rule, the thumb has to be placed in the direction of propagation. See here, you may start with right hand or left hand, it doesn't matter. But what is the condition? Your right hand thumb or the left hand thumb should always pointing out in the direction of propagation. So the direction of propagation may not be always outside. So in this example, I have taken my thumb by placing it outside. But what do you think in this case, in the same example, if it is plus beta z? You have to put the thumb into the board, right? So you have to be more careful. So the thumb has to be placed in the direction of propagation, which means in my example, the wave is propagating in the positive z. So the wave is propagating in the positive z. So as per the first thumb rule, the positive z represents outside the plane of the paper. So if I start with my right hand or left hand, I should always ensure that my thumb should pointing out in the outside to the plane of my paper. So what will happen, suppose if I give plus beta z here? Can you reply here? So instead of this question, if I give both plus here, what is the condition? Your direction of propagation will become negative z. So negative z, as per your thumb rule, it should be inside. So this time when you want to define whether it is right circular or left circular, you should start by putting the thumb into the plane. So let me not confusing you. So let us go back to minus beta z. So as per minus beta z means the wave propagates in plus beta, positive z. So positive z will be, as per thumb rule 1, it is outside. Now you start with your right hand and put the thumb outside. So the locus of the finger shows anti-clockwise, which is not matching to the locus of the points. Whereas when you put your left hand by placing the thumb out, the locus of the fingers is exactly matching to the locus of the points. So since left hand is satisfying that, so the answer is said to be left circular polarized. Now you understood? Still you have question? Yeah. I will tell you 3 techniques how you can cross check your answers. There are 3 possibilities of the mistakes where generally the students can do. So the first possibilities of the mistake was, you should consider at least 3 points. I have taken in my example t equal to 0, t equal to t by 4 and t equal to t by 2. So suppose what will happen if you consider only 2 points. So I have considered 1 point here, the other point here. If you consider only 2 points, what will be the problem? Can you tell me? What is the problem if you are going to get if you had only 2 points? Could be from any direction. Very good. You can't say whether it is a clockwise or anti-clockwise, right? So if you want to say it's a clockwise or anti-clockwise, minimum of 3 points should be required. So this thing you need to cross check once you are done with your answer. And the second step, you have to always consider the thumb rule 1. So what is the first thumb rule says? The horizontal cross vertical, you should consider it as outside. What is the meaning of that? So if you are taking x as horizontal, y as vertical, you should always consider positive z only is your outside the plane of the paper. And negative z should be into the plane. So if you are missing this thumb rule 1, your answer is going to be wrong. Similarly, what is the second thumb rule? The second thumb rule says your thumb has to be placed in direction of propagation. you're not concentrating on the direction of propagation, and if you always blindly putting the thumb always outside, your answer is going to be wrong. So first see the direction of propagation and verify that direction of propagation is outside or inside based on the thumb rule 1. So if it is outside the plane of the paper, you start by putting the thumb outside. If it is a vice versa, you can do the reverse thing. So these are the 3 possibilities of the mistake. Once you are done with your answer, you cross check all the 3 things. What will happen if you are 100% confident? Your answer is going to be 100% correct. And if you do one number of mistake, it's the problem. So if you want to do at least. So if you do any mistake, at least do 2 number of mistakes. So don't do 1. Okay, don't do 3. Okay, just was kidding. And so the final thing is, once you are done with that, you verify all this you have taken care or not. So once you are cross-checked all these 3 things, your answer is 100% going to be correct. And this is a very important topic in the GATE. Number of asking the question, and 70 to 80%, whatever the electric field they have given, it will be 75 to 80% it is a circular. But the only thing was you have to define whether it is right circular or left circular. That is the only challenging thing. So to do that, all these things you need to go through that. Okay, I will give another example and tell me. So it will be a practice. Okay, this seems to be complex, so I will give a simple one. So I will change another question, something like this. You take this example and tell me what is the answer. Take this one example and you take your own time. There is no hurry, and tell me whether it is right or left. But first of all, you have to be careful here. Is it a circular polarization? Look at the equation. No. So what kind of polarization it is? Elliptical. Very good. So see here, it is an elliptical polarization, but whether it is right elliptical or left elliptical, the procedure remains same. Whatever you have done in circular, the same thing you go ahead. So first split the components, define what is the thumb rule, and take the different points and plot it, and finally follow the second thumb rule. So the final answer becomes, if your right hand satisfies, it will be right elliptical. If your left hand satisfies, it is left elliptical. So the procedure what you have done for circular remains same. Yeah.
Sir?
Yes.
How is it elliptical? My theta should not be equal to 0, right?
No, in this case, theta is not 0, right? Theta is 90. You can see here one is sine and the other one is cos.
Oh, okay, sir.
Yeah. Good. You can go ahead. So first component, what you can split. So you can take x will be 2 sine omega t. Take y value will be 0. And y is equal to 3 cos omega t. Okay. And first, next thing was follow the thumb rule. So take x as horizontal. So this is your z, right? So the second component is not y here, it is z. So you can take z. Z is equal to 3 cos omega t. So you can take x as horizontal and z as vertical. So tell me what is the outside direction here? Positive y. That is the reason. You are always doing mistake here only. What is ax cross ay? What is the first thumb rule says? Horizontal cross vertical should be direction. So which is horizontal here? Your x-axis is horizontal and vertical is nothing but z-axis. So what is ax cross az? Yeah, it will be negative y. So you should be very careful with the cross product. So if you are taking x as horizontal and z as vertical, and you should consider your negative y is pointing outside the plane of the paper and positive y should be into the plane of the paper. Okay, then you go ahead and tell me all these values. At time t is equal to 0, what point you got? T by 4 and t by 2. So you do it quickly and tell me what is the points you got and whether you got clockwise or anti-clockwise. So can you tell me first at time t equal?
Hello.
Okay, now am I audible? Yeah, good. Okay, time t is equal to t by 4. What is the value you got? I'm not able to write here. I hope everybody done with that in the meantime. So once you plot the points, you are going to get it clockwise. Is it everybody? And in this case, the final step, what is the second step? So you have to follow the thumb rule too. So what is the second thumb rule? So you have to place your thumb in the direction of propagation. So what is the direction of propagation in this case? So I want everybody to reply here. What is the direction of propagation? Negative y. Very good. So as per your negative y, as per the first thumb rule, is it outside the plane of the paper or into the plane of the paper? It should be out. So what is the condition now? So whatever the hand you will satisfy, you will put, whether it is a right hand or left hand, you have to place it. The thumb has to be pointing outside. So again, the same story, right? When you start with your right hand, make sure that the thumb is pointing outside. So your locus of the fingers are anti-clockwise and the points are clockwise. So mismatch. So when you start with your left hand, place the thumb outside. Your locus of your finger shows clockwise. So since your left hand is satisfying, the answer is left elliptical polarized. Okay, good. So I will give another example. So see the next one there. So this is an example you can consider. Take the first one. So if you take the first one, is it a circular polarized or elliptical polarized? Circular polarized. Now in this case, there is no variation of time is there. So what to do? We always talking about the type of polarization by varying the value of time. So this kind of things you have to follow one different procedure. What is the first step? What you need to do? So in this case, you are having a component, y component. So me write x component, y component separate. So you can the coefficient of the x1 will be something. You can randomly assume something. So here there is a multiplier of 1. So I can take the x component will be 1 into sine omega t. Okay. The same sine omega t has also should multiply for the second term. You see here, when you are multiplying for the second term, what you are having, there will be always j. And you should multiply with sine omega t. So now is it clear? Now suppose or else you can take, if you take x multiplied as cos omega t, this also you can take it as cos omega t. So you got my point, everybody? So you can assume randomly it is sine omega t or cos omega t. So whatever you will multiply for the first component, do the same multiplication for the second component. Is it clear? What I meant to say? Have you understood? Yeah, randomly you can assume and multiply for both the components. So first I will explain like this. So I can take x is equal to 1 into sine omega t, and correspondingly your y, there is you have to remember here. So j into sine omega t. As you know that j is going to contribute for 90 degrees phase shift. So that will be omega t plus 90. So if I remove j, I can add plus 90 here. So what will happen? Your x component will be sine omega t and y component will be sine of 90 plus omega t. So that will be minus cos omega t. Agree? So in this case, what is the direction of propagation? First one. What is the direction of propagation for the first one? Positive z. Good. Because there is negative z here, direction of propagation is positive z. And the next thing, rest of the things and all same. If you take x as horizontal, y as vertical, accordingly your positive z will be outside and your negative z will be into the board. And the next thing I was leaving it to you, take for different values of time and plot the points and apply the second thumb rule. So will you be able to do the next section? I was leaving as an assignment to you. So are you able to do? Okay. So you can take multiply sine omega t for the x, the same thing you multiply it for this for second one. Similarly, you can do it for the second one also. Second one, what all the two components you are having? Y and z. Right. So when you are taking y, the magnitude you can take same thing, you multiply with sine omega t. And what will be the corresponding z component? Minus 2j into sine omega t. So the magnitude as it is I was taking, multiply sine omega t here, sine omega t here. So what will happen? This will be minus 2 into j can be replaced with omega t plus 90. So what is that? Sine of omega t plus 90, you are going to get cos, right? So your term will become minus 2 cos omega t. I think here I have done a mistake. Probably sine of omega t plus 90 is plus cos omega t. Correct? I hope you can understand this. So 90 plus omega t, when you are taking sine in the second quadrant, it is always positive. So this should be plus cos omega t. You just make the correction. So have you noticed that? So other than that, anything queries you have? So just answer me. If the kind of questions are given like this, will you be able to do it or not? You just assume it is a sine omega t or cos omega t. Multiply for both the two planar components as it is. So if I are taking sine omega t is the coefficient, multiply for the x component as well as the y component. So are you getting what I am saying? So I was leaving an assignment to you. So you solve this problem and post the answers in the WhatsApp group. Okay. So take your own time, no hurry, and solve these two problems and post your answers in the group. Okay. So we can sign out now for today. And if we and my suggestion was this topic is very, very important. And try to work out more number of problems. You can see in the previous gate questions, you will get a number of problems related to polarization, and you try to solve all those problems. You will automatically will get more confidence. Okay. So you can share the answers in the group. I will see that. So what kind and with explanation also. I need with explanation, not the straight away answer. Okay. So is there anything else to be clarified? Do you have any other things to be clarified?
There was this before power density. Actually, the recording was not done, right? So I missed that part.
Okay.
Could you?
So which power density? No, I have not recorded. Maybe it's first 5 minutes probably.
Okay, so you started with power density itself.
Correct. Yes, I started with power density. Yeah.
Okay, so fine.
Right. Okay, then you can sign out now. Maybe in the Friday class you can continue. Thank you.
Sir?
Yeah.
Sir, that tan of the loss tangent, that is sigma by omega epsilon. Sir, is it equals to tan of 2 theta? That is theta. That theta is the angle between E and H.
Okay. No. Loss tangent is not the angle between E and H. See, where you have studied this, loss tangent is the angle between your conduction current and displacement current.
Okay, sir.
Okay. So I will give an example so you can understand. I have given, right, sigma by omega epsilon. It is the angle between your conduction current density and displacement current density. Okay. So how it was your conduction current density is equal to sigma times E, right? And your displacement current is equal to epsilon times dou E by dou T. Okay. Dou by dou T can be replaced as omega epsilon into E. what will happen in this case when you are taking the angle between your JC and JD? It is of sigma by omega epsilon, right? You take JC by JD. Okay. Suppose, okay. When I define an angle something like this here, how to define the value of tan theta? Tan theta will be JC divided by JD. Correct? So what is the ratio? If you are taking JC divided by JD, you are going to get sigma by omega epsilon. This magnitude will be 1. Understood?
Yes.
Yeah. So that last tangent is the tangent of the angle between your conduction and the displacement current.
Okay.
It has nothing to do with E and H. Whereas when you are finding the phase angle between E and H, there is another formula. So what is the intrinsic impedance you have to take? What is the intrinsic impedance? Root over?
J omega mu by sigma plus J omega.
Correct. Correct. So in this case, what is the phase angle between E and H? So when you have the square root in a normal domain, it corresponds to 1 by 2 in phasor domain, right?
Yes, sir. Yes.
Yeah. Into, how can you define the phase of a fraction? Phase of numerator minus phase of denominator. Agree?
Yes, sir.
So phase of numerator is 90 degrees because it is purely imaginary.
Yes, sir.
And what is the phase of denominator?
Okay.
Tan inverse omega epsilon by sigma. So you can say the phase angle between E and H is not the last tangent. It is a 1 by 2 into 90 degrees minus tan inverse of 1 by last tangent.
Last tangent.
Yeah, correct?
Yes, sir.
Yeah. So any questions other than that?
No. It's okay.
Yeah. That's it.
Sir, because what happened is like trying to solve some solved examples.
Okay.
But actually they are using this formula, that is whatever is that is eta n angle, they are directly taking it as a tan 2 theta, that is tan of twice of that angle equals to this lost tangent. They are taking.
No. That will happen when you don't have any this 90 degrees angle. So they would have been referred to this one. When you don't have this particular angle, your 2 theta becomes tan inverse 1 by last tangent, right?
Okay. So that is wrong then, sir. Right?
No. That is wrong. That is wrong. So if you consider, I was talking about this is the generalized equation irrespective of whether the medium is lossy or lossless.
Okay.
Okay, this is the generalized equation. That may be the peculiar case. It depends upon the type of medium.
So we cannot do this like this, right?
No. If that kind of medium, suppose if you have, it is a basically what you can say, non-permeable medium. Non-permeable medium means you can approximate your relative permittivity to 0. Okay. In that case, your numerator doesn't have any phase shift, right?
Yeah. That's why we can do that.
Yeah. That case, your 2 theta become tan inverse of 1 over last tangent. So that is a special kind of medium, but that kind of medium generally will not exist.
Yeah.
Okay. And this is the generalized equation irrespective of whatever the medium it is. So that is not correct.
Okay.
Yeah. Okay then.
Yeah. Thank you.
Okay then. If you have any questions, you can discuss in the WhatsApp group also. Not a problem. So you can sign out now.